Comprehensive explanation of Kubernetes ClusterIP service workflow. Overview. The ClusterIP service in Kubernetes is the default service type that provides a stable internal IP address for communication within the cluster. It abstracts the underlying backend pods, enabling seamless communication between services and pods. This workflow explains the end-to-end request handling process in a Kubernetes ClusterIP service, highlighting how client requests are routed to backend pods using Kube Proxy and endpoint objects. Step-by-step explanation. 1. Client initiates a request. The client, which is typically another pod within the cluster, sends a request to the ClusterIP service. The service's virtual IP, ClusterIP, acts as the target address for the request. This IP is internally exposed within the cluster and provides a consistent access point for backend services. 2. ClusterIP service receives the request. The ClusterIP service receives the request and determines the backend pods associated with it. These backend pods are managed dynamically and are abstracted from the client. 3. Forwarding request to Kube Proxy. The ClusterIP service forwards the request to Kube Proxy, a critical component responsible for routing and load balancing. Kube Proxy ensures that requests are routed only to healthy pods using Kubernetes endpoint objects. 4. Kube Proxy identifies available pods. Kube Proxy queries the endpoint objects, which maintain a list of all pods associated with the service. The endpoint list ensures that only ready and healthy pods are considered for processing client requests. 5. Pod selection and load balancing. Kube Proxy selects a backend pod based on its configured load balancing algorithm, such as round-robin or random selection. If pod 1 is selected, the request is forwarded to pod 1, which processes it and returns a response. If pod 2 is selected, the same workflow applies. This ensures a fair distribution of traffic across all available backend pods. 6. Response handling. Once the selected pod processes the request, it sends the response back to Kube Proxy. Kube Proxy forwards the response to the ClusterIP service, maintaining the abstraction layer between clients and backend pods. 7. Response sent to client. The ClusterIP service forwards the response to the client pod, completing the workflow. At this stage, the client has successfully interacted with the service without needing to know the details of the backend pods. Key features of the workflow. 1. Abstraction with ClusterIP provides a stable and consistent interface for accessing backend pods without exposing their details. 2. Endpoint management ensures that only healthy pods are considered for handling requests, enhancing reliability. 3. Load balancing distributes traffic evenly across backend pods, ensuring scalability. 4. Kube Proxy handles the routing and load balancing of requests, simplifying service interactions. 5. Transparency. Clients can communicate with services without needing to track individual pod IPs or statuses. Conclusion. This workflow demonstrates how Kubernetes efficiently routes traffic within the cluster using ClusterIP services. The combination of Kube Proxy, endpoint objects, and the ClusterIP abstraction ensures reliable, scalable, and seamless communication between client pods and backend services.